So what I want to do is talk about them, go over them, and make sure we truly can do our order of operations. So if we look at example number 1, there are no parentheses and there are no exponents. However, we do have multiplication. So the multiplication supersedes the subtraction. So when I look at that problem, the first thing I want to do, and I always want to read my math problems left to right, the same way you read a book. So we're going to take 8 times 3 first to get 24. Maintain the subtraction sign, and then we can also multiply 2 times 8, or 2 times 4, rather, to get 8. Now I've eliminated multiplication, there's no division. Reading it like a book, I see 24 minus 8, so I get 16. Okay, number 2, we have 8 minus 4 plus 6 divided by 3. So the first operation I have in order of operations is division. So I'm going to ignore the 8 minus 4 plus. I'm just going to tag it along. And I'm going to take 6 and divide it by 3 to get 2. Now I'm down to just subtraction and addition, so I'm going to read it left to right. So 8 minus 4 is 4. 4 plus 2 is 6. Okay, here, and this is where reading the multiplication and division, or the addition and subtraction together, is important, because reading this left to right, the first operation is 24 divided by 12. So we get 2. And then the times 4 divided by 3 sort of tags along. Now I want to multiply 2 times 4 before I divide by 3. So I get 8 divided by 3. 8 doesn't divide nicely by 3, and it is going to be what we call a repeating decimal. So we can actually rewrite 8 divided by 3 as a fraction. If you put 8 divided by 3 on your graphing calculators, and I want to teach you a little trick right now because a lot of you don't know how to do this, go ahead and type 8 divided by 3. Remember, the division sign on the calculator is, well, I guess it looks like a division sign, but when you type it, it looks like the slash. So when you do that, you get this decimal, right? You probably get 2.6 repeating, I think. If you want to know what that is as a fraction, there's the third button down on the left side called Math. So if you look on the far left side of the calculator, the third button down is Math. Go ahead and hit that, and hit Enter, Enter twice. Did it give you a nice fraction now? Did it take that decimal, that long thing, and turn it into 8/3 for you? So anytime you get a decimal that's like not pretty, or you want to know what it is as a fraction, because maybe it's a multiple choice test and you have to know the fraction, or maybe it says give your answer as a fraction, the graphing calculator can still give you fractions the same way the other calculators did with you, with that like second F to D button. But now instead of showing you that button, you hit Math, Enter, Enter. Yes? Multiplication and division go hand in hand, but you read them left to right like a book. So that's why I keep saying it's important that when you do your math, you read it like you read a book. You do the multiplication and division together, left to right.
Would it be acceptable if we just leave it as 2.66?
So if you want to put it as the 2.66 number, what you have to do is put the repeating bar for me on top of the 6. Like, you need to recognize it's a repeating decimal. And then, yes, it's perfectly fine as long as you put the little bar. Yep.
Would it be acceptable if we put 2 2/3?
Yep, that's fine too. So if you want to turn 8/3 into a mixed number instead of improper, you could also have had 2 and 2/3. So what's super crazy in math is that all these numbers are the exact same value. they all mean the exact same thing. So you can get the same answer in math and write it in a bunch of different ways, but all three of those are correct, and I would take any of those three. Okay, number 4. In number 4, we have our first example of an exponent. So the first thing we need to do in number 4 is 8 squared. That's the very first thing I need to do. If I did anything other than 8 squared, my answer is probably not right. So it's 3 times 64 plus 12 divided by 4. Now, reading this like a book, left to right, I'm going to multiply 3 times 64, and then I'm going to divide 12 by 4. So again, I can do multiplication and division in the same steps. Add them together. Oh yeah, 195. Okay, number 5. 27 plus, well, that's adding, so we're not going to do anything with that to start. We're not doing division yet because we're still on exponents, so we're going to keep writing the divided by 9. Now we have minus 3 squared, so here's my exponent. Going to turn that to 9, add 1. Now I have to ignore multiplication, or ignore addition and subtraction, and look for multiplication and division. So the only multiplication and division I have is 18 divided by 9. So the 27 plus tags along, the minus 9, the plus 1 tags along, and we replace 18 divided by 9 with 2. 27 plus 2 is 29. 29 minus 9 is 20. Add 1. And we get 21. What's going on in the last one? Left to right, we have parentheses first. 20 and 4 and 40 is 64. And then we have 2 cubed, which is 8. Plus 1, which is 9. Carry on the negative 1 at the end. Next operation is division. 64 divided by 8 is 8. So you have minus 9 minus 1. 8 minus 9 is negative 1. Negative 1 take away a negative 1. And we're left with negative 2. So let's talk about some vocabulary again. We will have a quiz on 1-1 through 1-3. So we're going to do 1-1 today, 1-1 tomorrow. 1-2 and 1-3 are a little quicker. I can promise you on your 1-1 to 1-3 quiz there are multiple choice vocabulary parts to it. So knowing the vocabulary for this part of the chapter is very important. A variable. A variable is a symbol, usually a letter, used to represent one or more numbers. So in the example 3x plus 1, x is our variable. In the example 3x plus 1, x is our variable. An expression typically contains one or more variables and does not have an equal sign. An expression will not have an equal sign. Equations have equal signs. Expressions do not. So 3x plus 1 can be considered an algebraic expression. The word evaluate is a way of describing or saying to substitute. The The word evaluate is another way to describe or say to substitute. So the directions may say evaluate the expression or blank equals blank. When we are evaluating, and this is why we did the order of operations warm-up, it is very important to still remember our order of operations. So let's start with some examples and work our way through. We have evaluate the expression k minus 18 squared minus 4k for the value k equals 4. So what we're going to do is everywhere you see a k, we're going to replace that k with the number 6. So everywhere you see a k, put in a number 6. So we have 6 minus 18 squared minus 4 times 6. Now we're just going to follow order of operations and simplify. 6 minus 18 is negative 12. When you type in negative 12 on the graphing calculator, you have to put the negative 12 in parentheses exactly as I did on the board. Because what do you know about a negative times a negative? You're going to get a positive. If you type negative 12 squared on the calculator without parentheses, it's going to tell you negative 144. Because your calculator is doing order of operations the way it thinks you want it to. It thinks you're saying, okay, 12 squared times negative 1. When in reality, you're trying to say negative 12 times negative 12. So anytime you square a number on a graphing calculator, put it in parentheses. Anytime you square a number on the graphing calculator, put it in parentheses. I cannot tell you how much it will save you as we progress. So if you're going to square something or cube it or fourth root it or whatever, put it in parentheses. Typically, if I write it in parentheses on the board, you want to put it on your calculator the same way. So, and then we know 4 times 6 is 24. So again, we know a negative times a negative gives us a positive 144. Take away 24, and we get a positive 120. Again, you are smarter than the graphing calculator. You are smarter than the graphing calculator. Okay, let's look at example 2. We have 7x minus 3xy for x equals negative 2 and y equals 5. This time, it's 2 variables we're plugging in for. So everywhere you have an x, make it negative 2. Everywhere you have a y, make it 5. So you get 7, the negative 2, minus 3, negative 2, positive 5. So order of operations says multiply before subtraction. So 7 and negative 2 is negative 14 minus 3
3 times negative 2, which is negative 6. Negative 6 times 5 is negative 30. What do you know about subtracting a negative? Minus a minus becomes a. So we have 30 being added to negative 14 to get a final answer of 16. For 3, 4, and 5, we're going to continuously use the idea that x is 4 and y is negative 2. So anywhere you have an x, you're going to put 4. Anywhere you have a y, you're going to put negative 2. So once we plug in the x and y's, these are exactly like the warm-up problems. It's just a bunch of numbers, and we're following order of operations. So right here, we have 4 plus negative 2 divided by 4. This one's the one I think we always want to fall for the trap. We want to do 4 minus 2 and then divide by 4. Make sure you follow that order of operations. It's negative 2 divided by 4 first. Then you add it to the 4. So you get 4 plus negative 2 divided by 4 is negative 1/2. Or if you did it on your calculator and you left it as a decimal, it might have looked like 4 and negative 0.5. Either are fine. And both ultimately give 4 minus 1/2, which is 3.5. Yes.
How usually you're supposed to get the fractions?
Math, enter. So it is the third button down on the left. So it's right under the little green button. And then you just hit like the enter key twice, which is the very far right button. Okay, let's look at, did you get it? Yeah. Let's look at number 4. We have 3 times x. So you get 3 times 4 minus 4 times y plus x, which is 4, minus, here's where you got to be careful, it's minus a minus 2, which we know turns to a positive. So it's fine, you can make that a positive, just don't lose the fact that it was minus a minus. So following order of operations, we're going to multiply first. So 3 times 4 is 12, and 8 times negative 2, or 4 times negative 2 is negative 8, plus 4, and we turn the minus minus to a plus 2. Here I have another minus minus case, so we can turn those to both positives. So you get 12 plus 8, which is 20, plus 4, which is 24, plus 2, which is 26. Okay, replace x with 4, y with negative 2, and follow order of operations. So 4 plus tags along. Multiplication first gives 8, divided by negative 2 times negative 2 times negative 2. Because again, we have to read it left to right, so now I have to do division first. So I have 4 plus 8 divided by negative 2, which is -4. Subtracting 2 times -2, which is -4. 4 minus 4 is 0. The negative turns into a positive, and we get 4. So go ahead, take a minute, and try 6, 7, and 8 on your own by plugging them in and using order of operations. Remember, if you square it, put it in parentheses on the graphing calculator. Okay, once you've finished, you may look up at the front board. The work is there for those last 3 problems.
Why is it in the text that calculated -332?
Okay. So I think the first one, number 6, was maybe the one we made the most mistakes on again, and we might have actually made similar mistakes here with the -9. Be careful, you have to wrap -3 in parentheses. Otherwise, your calculator is going to tell you -9, and then you have -9 and -25, and then we put 34. Number 6 was not 34 because it is not -9, it is +9, because any number squared is positive. Okay, I know how much we love word problems. So number 9, we have the expression above models the percent increase of voters from 1990 to 2000. In the expression, y is the number of years. Find the approximate percent of increase in voters by 1998. So again, from 1990 to 1998 was 8 years. So what you want to do is you want to put in y equals 8 for that equation. So you have -0.08, 8 squared plus 3 times 8. So again, it says what was the increase in voters? Well, the increase was 18.88%. In 10, you have the model for the expression of eligible voters. In the expression, y is the number of years since 1960. What percent of eligible voters will vote in 2012 and in 2020? So what that means is we need the number of years from 1960 to 2012 and the number of years from 2020 to 1960. So you want to take 2020 minus 1960 and 2012 minus 1960. And what that's going to do is that's going to give you the number of years. And then what you want to do with that number here is just simply plug it back into your model. So a lot of these problems is being able to type and get values on a graphing calculator following order of operations. So what I want you to do for tonight is just the front of this handout. So I know there's a back, you're just doing the front. for tonight, you are just doing the front of the handout.